I've finished off the wheel design by putting in a recessed hole, which is just a simple cylinder with a planar surface at the back, to accommodate the bolts that I've provided on the bolts layer. So to prepare this for prototyping, I'm going to need to check for gaps. So I'll stitch, and I'll just check that I've got the right tolerances set. So I'll go to the surface edit and do the stitch. Now most of that's looking good. These open edges here are okay because they'll be closed once I copy the segments. But down here I've got this yellow edge. So let's delete the shell and investigate. And often the problem will be a double surface. So if I pick there, I've got two surfaces in the same place. I'm not sure how it happened, but it's very common. So I'll just get rid of one of them, and then I can stitch again to see if that solves the problem. And that's now looking fine. So over here I've got a partial yellow line. So I'll delete the shell and double check the edge with the surface continuity check. So yes, that confirms it is a real problem. And if I use the right mouse button, it tells me that it's very slightly outside of the tolerance. Now I built that a while ago, so I can't remember if I was using the right tolerances or not. So I'm just going to intersect them again to see if I can fix it. So I'll do a hide unselected to isolate those two surfaces. And I'll start with my accurate tolerances. And I'll do an untrim, delete the old curve on surface, and then re-intersect them again and trim. So then if I stitch again, I get the same problem. So now my only option is to make a new set of tolerances and make the trim curve fit even more accurate. So I'll go down to 0.0005. And then I just need to untrim, get rid of the old curve on surface, intersect again and trim. And then the important thing is to go back to my normal tolerances and see if it'll stitch now. And that fixes the problem. So a lot of people end up with a second set of tolerances which they use for problem solving like this. And you don't want to use them all the time because they'll slow down your modelling and make the surfaces more complex. But they're useful for situations like this. So I'll make sure I'm using my normal tolerances and then bring back all the other surfaces. And now I can stitch it again to see if we've fixed everything. And I've got the two open edges I'd expect, but there's also this arrow up here. But I can't see a yellow edge. So let's check that out with the surface continuity tool and try and find out which edge has the problem. So if I use my middle mouse button here, there's no comb plot showing. Just this tiny brown line at the end. And if I'm struggling to click on that with the right-hand mouse key, then I can always use the information window. And that shows the gap tolerance we're measuring to and the maximum gap as 0.001142. So it's just slightly out of tolerance. And the fact that I'm not seeing a comb plot means that the problem really is only on that single point at the end. So if I'm sending that out for rapid prototyping, I'd choose to leave that one, as it can probably be fixed by the supplier during the 3D printing process. But if I was sending it out to engineering, then I'd need to rebuild the fillets or the rounds again at a tighter tolerance and get it fixed. So let's say we're doing prototyping, and if I just want to see that stitching without any gaps, then I can cheat a bit and choose a slightly looser tolerance such as Pro Engineer, and then it should stitch without any errors. So finally I want to create and check the whole wheel. So I'll just template the curves and then pick the surfaces and mirror them. And then if I pick both halves, I can do an edit duplicate object. And I've got my 4 duplicates and 72 degrees, and this time I'm not using instants, I want real copies. So I'll say go. And that gives me the whole wheel. And so finally I need to check if there are any gaps between the segments. So I'll do another stitch, and remember that's at Pro Engineer tolerances, so we're not seeing that tiny gap that we think we can get away with. And that looks fine. So for a design review, then I might decide to just prototype the front portion. So then I'd just need to close off the back with a skin surface. But before I build that, I'm going to go back to my more accurate tolerances. And quite often we'll need to do a little bit of extra modelling like this to set up for a prototype. So let's see if that will stitch. And I'll go back to the Pro Engineer tolerances to give myself a bit of leeway. And then stitch all those surfaces. And that's looking good. And if I just move that off to the side, I've now got a stitch model ready for prototyping. And depending on what equipment you've got, you could probably just about fit a wheel on a large rapid prototype machine. So I could then export it out as a polygon model for 3D printing. So have a go at creating a finished closed model of a wheel. So a wheel is quite a challenging project, but it's much more manageable than a whole car exterior. So it's a really good way to develop and practice your Alias skills.